So, finally, Szymon Jakubowski from Akamai will talk about the secure system with the open source best practices. So, stage is yours.
Thank you so much. No need for the applause yet. All right, so yeah, I'll be talking about best practices for building secure systems using open source software, right? We all love open source software, especially CNCF projects at Akamai. We also like them and use them extensively. But with this, there's always a design question. Whenever we try to solve a problem, we first ask ourselves the question of whether we want to build something, whether we use something off-the-shelf open source software, preferably a CNCF project, or whether we buy a solution. And by buy, it goes two ways. Either we buy something completely closed source, a whole ecosystem, a fully managed service, or we can also use something open source and just extend and buy support, for example, which we will talk a little bit about later. But as with everything, the whole million-dollar question is always risk versus reward. How much risk do we take on by going a certain way, and how much rewards do we get for that? And do we meet our requirements? So that's always the fine line to walk. And what are some of the risks when working with open source software? Well, first of all, licensing risk. This has come up several times in the past years, where there's something we use, we adopt as a system, we put it as a component of our system. Sometimes we make a product out of it, so we resell it. But this comes with certain risks, right? Can we use it that way? What happens if the business model changes, which happened with, for example, Redis recently, right? We can end up in a situation where we thought this is open source, we can freely use it, but then in the end, it didn't really work out that way, and we're at the risk of having to cash out a lot. So this is one of the things we have to take into consideration. What about support and specifically incidents? Something breaks, our platform is down, our product is down, our customers cannot use it. Well, what? You go open up a GitHub issue and wait, right? That doesn't really work. That's a risk and and something to think about. Roadmap planning. Open source is great, but it's not everything is fully predictable. Sometimes you know there will be a patch coming every year, a major version, a minor version. Sometimes there's a full release cycle. Sometimes there is none. You're at the mercy of the maintainers. You get what you get. What about supportability concerns, right? So all of us use different tech stacks. For example, when you're running your Kubernetes on your nodes, what kind of distribution are you running? And the distribution you're planning to run, will it support your ecosystem and your tech stack? And then interoperability. So you have likely other tools that already exist there. Will what you're introducing into your system work with those tools in a good way? And then the vendor lock-in. You buy an iPhone, next thing you know, you want a Mac, and then you want an Apple Watch, and then you want something else. It's the same story with all of our cloud products and our open source software. Sometimes you choose one solution, and pretty much everything else you have to follow and use from that same vendor because it works the best, it has the best supportability, interoperability, gives the most features, etc., etc. But with that comes a risk and danger of vendor lock-in. What if, for example, there's now this license risk and when you have to move away, or we have to now work with a completely different lower budget, or we have to move away somewhere else? What do we do, right? Well, if you're locked in, you don't have that flexibility of going elsewhere because you have to redesign or rewrite your system. And then various security concerns. The list is fairly large, but of course, authentication, authorization, and access control in general. Data safety these days very important as well. And the so ever mentioned supply chain attacks, where the bad guys often go after the weakest link, and often it's not us, but one of our supporters or providers that we trust. Supply chain attacks, of course, have been very. There have been many instances throughout the years, and increasingly in various types. The executils backdoor in Linux last year, the polyfill one. So these are, of course, examples of some of the larger ones. We also had a lot of the NPM and Python packages issues with typo squatting, and of course just pure taking over of the packages that are maintained and most commonly used, and then often these are riddled with or infected with malware or other types of software, malicious software. And then it keeps getting worse and worse. So what do we do and how do we protect ourselves against those risks, and how do we think about secure system design? So the first thing is this shift left motion or idea. It comes from testing, but in general this applies here as well. It's when we should start thinking about those things when we design the software. At this point we have many tools and it's great, oh, let's do this, let's use that. But we have to circle back and think about the design, how we want to address this. And the first best practice is to start with your requirements. Make sure you have your requirements nailed down. And there's two groups of requirements: your functional requirements, which would be your use cases, your prioritization. What do you want to actually achieve with the system? What do you want to do, either a system, a product, or a component of that? And then a bunch of these requirements, which we'll go over in a second, so I'll not list them all here, but all other non-functional requirements, which are really important to drive further decisions. So let's talk about some of these. So whenever we're choosing open source software and we're thinking about, how do we design this in a secure way or implement this in a secure way, we have to think about the data. What data will we be processing? Will it be customer data? Is it only an internal system? Will there be credit information, so personal credit information, personal financial information, personally identifiable information, the health information, et cetera, right? So knowing all of that in advance will really help us to also understand how much of data security we need to build in, and in general security. Now, what about data localization? So where do we store that data? So the whole data lifecycle, pretty much, right? Where do we store this? How do we process it? And then what is it used for? Which is the purpose. Other things we want to think about: safety. What are our safety requirements? There's often the concept of secure versus safe, right? Secure is not equal to compliant. But the same goes for something is secure, but is it safe to use? That's another question to ask. And here we have to think about things like, hey, is our system or something we're designing mission critical? Is it revenue generating? That drives, again, further requirements and design decisions that we have to make. What are our acceptable and unacceptable losses? So what cannot in any way, shape, or form happen that we have to absolutely avoid, right? Think about it. If you're designing a nuclear reactor, then a nuclear meltdown is the absolute unacceptable loss, right? Same here applies in system design. This is how you want to think about it. And also, how do we handle error states in our systems and fault tolerance? And then in terms of security requirements, that's not me, I think. In terms of security requirements, access control, so our authentication authorization. If we're pulling in a whole new system, how will we handle authentication to it? Do we have any SAML SSO requirements or integration with other providers? Do we require RBAC, ABAC, PBAC, or any of the other access control systems? What is our vulnerability and patch management story internally, right? Do we have to patch certain things in a given SLA? How is this product or the solution we're choosing, the open source solution we're choosing, how is it maintained, and how often do vulnerabilities come around and patches come around? How do we deal with secrets? Very important as well. The secrets are the keys to the kingdom, right? So we want to make sure we have a good story around secrets, especially on the operational side as well, where if we're dealing with certificates, we all know certificate rotations and other things can be tricky. So secret management and the operationalization of this is really important. And then data safety, as I mentioned earlier as well, is really crucial as well. So how do we protect our data at rest, and how do we protect our data in transit? Then the beloved alphabet soup of compliance requirements. So if we're a publicly traded company in the US, there's laws that we have to obey to SOX. If we're dealing with credit card data, we have to do PCI DSS. If there is health information, then HIPAA applies. Then we got SOC 2, ISO, and then the government-style compliance regimes like FedRAMP, ISMAP, IRAP. The list goes on. These often is very important to remember about compliance of those. Some of these are very particular, one like FedRAMP, for example. FedRAMP requires you to have cryptography as an example. There's like 300-something controls. One of them is cryptography has to be from FIPS compliant providers. So now if in terms of Kubernetes solutions, there's not many who can offer that. So really, sometimes a simple requirement as this can really impact our design choices and what solution we actually choose and how we implement it in a secure way. Okay, and then of course availability requirements, right? What is our expectation internally, so in terms of SLOs, and if there's any contractual obligations to our customers. We say our platform offers a guaranteed uptime of 2 nines, 4 nines, 3 nines, et cetera, et cetera. This also dictates how much actual planned downtime we can have, and amongst other things. Disaster recovery, what are our RTOs, RPOs, all of those metrics related to disaster recovery. How do we deal with scenarios where our entire control plane goes down? All of our worker nodes are out in a given region. And then the same applies for performance, right? How quick do we want our responses to be, and what is our SLAs and SLOs around performance? Again, same story. Do we have any contractual obligations? Do we have marketing claims? Ours is 3 times as fast or always responds within a second. So these, if we have those requirements and those claims, we have to make sure by design that whatever solution we choose, we'll be able to meet those requirements in terms of performance. And then scalability, very important. We have to understand what scale we have to start with, how will it scale into time, how do we manage capacity planning, increasing capability, and then of course horizontal versus vertical scaling. Is there auto-scaling enabled as part of this solution? So these are all requirements and things to think about. Observability, of course, a big one. How do we where do we log? Where do we do the monitoring? Where do we do the alerting? How do we do auditing and tracking of all the changes happening in our platform? And then product related, right? So sometimes, like I mentioned, some of these things will be just around the product itself. Are there any legal requirements, specific timelines? Do we have a deadline to deliver this product or system? Yeah, and then experience and people, which is sometimes often forgotten, but not everyone has the best engineers who can learn any other tool at any other time, right? Often we have engineering teams that have specific experience. Sometimes there's budgeting. We cannot get more people as part of a system, new system or system redesign. So will the current people we have be able to understand, implement this solution? Will they be able to maybe attend any training? And then do we have enough people to actually implement such a solution? And then maturity of the product itself, right? So often open source offers you many alternatives. But if you're doing something for yourself, your personal website, but you're dealing with an enterprise-grade system that handles thousands, millions of users, that's completely different scale and completely different questions you have to ask yourself. And one of these is how mature is the product you're going to use, right? The less mature it is, the less it's used in production. So is there any production use for it? Do they offer long-term support versions that we can stay longer on? Perhaps in enterprise-grade systems with very high availability, we don't want to be pushing changes very often unless we have to. So these are all things to think about in terms of requirements. Now, when we have our requirements set, we have to compare solutions. You're trying to, for example, given this is KCD Kubernetes Community Days, let's pick on Kubernetes, right? You're going to build out a microservice platform based on Kubernetes, right? So you have to compare solutions now, or you should at least compare solutions. There's many out there. First choice, do we go for a fully managed service in cloud, or do we self-host and self-manage? And then once you are within those, once you've decided, we have to, for example, for security reasons or other reasons, we have to self-host, self-manage, then there's a couple solutions. Which one do we choose, right? So it's also important that we compare apples to apples here, rather than cross-referencing different solutions that would be the comparing apples to oranges. Once you have your architecture and things written down, then you go over the risks. Hey, what are our risks in this system? No solution is perfect. No solution will give you everything and meet all of the requirements. So there will be certainly risks around every solution you're going to implement. The big question is now, which risks can we work around, and which risks can we accept, right? And what is our essentially risk strategy, which is the next point, right? So first of all, make sure we list all of the risks. We know what their impacts are. If this goes south, then this is our business impact. So if we have this written down, we understand this, then someone can take the decision of whether this is a go or a no-go. And then we define risk strategies. So let's look at some of the things I have discussed earlier around open source software. What kind of risk strategies, what can we do to avoid some of those risks? So when it comes to licensing risks, first it's really important to understand the model of the company who's maintaining or the maintainers of the software, open source software component we're going to use, and what business and what direction they're heading, right? If they're just going to offer support and the software will stay open source, then that's maybe a good choice. Then other things, these licenses are often hard to understand, and there's a bunch of them. So it's good if you have a process and guidance around, hey, for example, if you're choosing open source software, here's licenses that we think you could pretty much use out of the box and we don't have any issues. Here are some licenses that, if you see those, you should really contact our team, and maybe it's okay for those use cases, but you shouldn't be selling it as a product, or you shouldn't be advertising it to customers, maybe okay for internal usage only. And then there's licenses that complete no-go, or licenses that just would say require a review. And it's ideal if that review process and guidance is also done by someone who's a legal person, actually understands those licenses very well. What about support? So when things are breaking, so there's two ways. Often companies will offer support, paid support, so you can still use open source, but you'll get a license for support. And anytime you need something, anything breaks, you don't have to just open up a GitHub issue. You can go straight to their support, and get it resolved. But again, comes with cost. Question is, do we have this in our budget requirements, or will it fit into our budget? If not, this is the beauty of open source as well. Will our engineers be able to contribute to this? If something breaks, can they go and dig through the source code? Can they figure out what's broken, make their own PR, and fix it themselves? Or do we really need to, or can they, maintain this themselves pretty much? Or even better, contribute, right? Because that's the whole point about open source software, so that anybody can contribute. So that would be also great. But it's a question to ask and something to look at. Again, that comes back to that question of whether our engineering staff is comfortable with this solution and supporting it, and implementing and supporting it. Roadmap planning. Again, mostly this varies a lot. Some companies do offer also as part of the paid plan. Not only do you get the support, but you also get actual predictable roadmap, and they'll tell you, we'll do a minor release every quarter, and then every second release is a major release. So you have 2 minor releases every in a year, and then you can plan your work ahead. However, this is also, you can work around this. Same with vulnerabilities. You never know when they show up, right, in your software, and then you gotta fix them. So same here. There is ways to work around it. You just say, you know, there's every month there's a buffer of work that we have, either for vulnerability patches or for taking patches. And then, of course, major versions often have breaking changes, so these probably require larger thinking ahead. But often maintainers will announce that there is a major release in the cooks, and it is going to have breaking changes, so people can start looking at this early. So what is still a concern, it will depend whether it's a large one or not. And then supportability and interoperability. So here, make sure it is actually supporting the systems and the tooling you use. And then the vendor lock-in, and here, you know, the best way is either you accept it, right? You just say, okay, that's the best solution, we'll have to work with this, or go back to the drawing board and pick something else that will offer you working with other tooling or moving elsewhere in the future. When it comes to security concerns and before mentioned supply chain attacks, what can we do around open source software? So first of all, you can open source. You can fork it and you can host it yourself. If you have your own private repositories, just fork it over there. And then if the main repository is somehow compromised, there is a change, there is a commit merged into the main branch, you're not affected because you have a proxy, you have a copy that you're maintaining yourself. Of course, all of these solutions sound perfect, but you have to have in mind that these will require overhead in resources, and someone has to actually maintain that copy. But again, risk versus reward. Once then, of course, so you fork it once, and then you have to backport and keep having it in sync. Also, once you have it in your system, don't use the ready product, build it yourself. That's also a much better way than using the ready product. Then once you've built it, you have it somewhere in a repository. Why not have it in your own repository? When you're using Helm charts, how many of you just use straight up Helm chart repositories from companies? Some hands, okay. I guess, so the best practice here is actually have your own repository. You can store everything there, and again, avoids this issue of if it's being compromised, then you're straight away compromised. This was the issue, for example, with, I'll talk about this in a second, self-hosting, right? Where polyfill, for example, that's often with JavaScript. Oh, why do I have to host it myself? I'll just put in the CDN link there. And yeah, but if that is compromised, then you're affected straight away, and you have really no way to prevent this from happening. So self-hosting is a great way. And then while you're having all of the source code, you're building it, you're storing it, you're building it, you're releasing it yourself, then you can do all kinds of analysis on it. You can review it manually, of course, which is not recommended, but there's toolings where you can look for vulnerabilities yourself. You can look for static code analysis and report those as you find them to the community, or fix them yourselves and contribute the fixes. And then, you know, whenever we buy something and it's a third-party solution hosted somewhere else, do your due diligence. So all the things we look at security-wise, how we would protect our own system, you should expect that the vendor protects it the same way. And then best practice number 5 is proof of concept and testing. So I talked a little bit, mostly what I talked about is paperwork. It's just making sure you write down all of your requirements, you do your work in terms of research, you put it all together, you come up with a recommendation. That's most of the design work and the architecture work. But then it's also good to test drive this. Write a POC and see whether what we've laid out in our requirements and our designs actually is implementable and doable. Additionally, so this helps again claim any assumptions we had about the systems or the architecture of that system, and clarify any claims and make sure they're actually true. Again, helps with making sure this is not only on paper but actually works in practice. And then start small scale with a small POC and then build it up. Really recommend it. Build it up to the actual scale you're going to have or want. That's not always fully possible, but at least you should try, especially if you're having scalability or load concerns, whether a certain solution can scale up to a level that we want. Best way to find out is build it and test it. Just throw load tests at it. That's what we do. And then capture all the requirements, and that again fuels back to that design decision of what we want to choose. And then don't be afraid. Maybe everything sounded great on paper, everything was perfect, but it turns out it was just marketing claims, and it didn't work out for us. The specific use cases we had, the specific type of loads we were trying to run did not work out. Again, it's okay to just go back to the drawing board if this didn't work out. All right, that was pretty much it from me for this session. So let's recap what I talked a little bit about today. So you start with as early as possible, and when introducing different open source software components into your system or architecture, make sure you got those requirements nailed. They really help make a good choice, and make sure you implement this correctly. Compare as many solutions as possible. Again, that apple-to-apple comparison is the best, so similar solutions or with similar feature sets. Then make sure you capture your risks, you understand the impacts of those risks. Define a risk strategy. What I'm going to do about this certain risk or those risks that I've listed previously. And then write a POC and test it out. That's it from me. I'm open to questions now because I think we have, I don't know how much time we have left. Okay. We got plenty time.
Okay, so thank you. Any questions to our beloved speaker?
I'm not sure about the beloved one, but.
All right, thank you for the presentation.
Yeah, no problem.
A question that happens to me somewhat often when an engineer comes very excited with one of these brand new shiny open source things, and you gotta make a decision about doubling down and going through what you mentioned about measuring all those things or not. Do you have any tips to take a decision in a way that you won't commit enough time, that you struggle with capacity, but you also will not rule out something that can be very good? Like, what is the balance? Because I understand that those things are very necessary, but you don't want to go through every single possibility through all of those because it takes time, right? So what are things you would consider for this decision?
Yeah, so that's a great question. My answer to this is above my pay grade, because actually such questions I would defer to my management, because really they own the resourcing, right, and they have to understand what is the fine line of, okay, this is the time we can commit to innovation, this is the time we can commit to research, pretty much R&D time, right? And this is the time that we have to actually spend building, shipping features, fixing bugs, fixing vulnerabilities, and all of the other 5,000 things we have to do as engineers on a daily basis. So as an architect, really, I often provide just recommendations, and I say, hey, you know, one of my engineers wrote this 60 pages document about a cool thing he saw, a new open source tool that would really help maybe our platform. And now my manager goes like, I don't have, why did he spend time to write 60 pages? And my manager says, I don't have time to read 60 pages. So I'm always the middleman who read through that and often say, okay, I see value in this. We should definitely pursue this and spend that much time with it. The other thing I think really comes down also to prioritization. What hurts the most? If it's something that's really important to product management, to the business owners, to the engineering owners of that system and product, the more this goes in line of helping to fix that problem, makes things better for everyone, or even better bring in revenue, then you're gonna have a much better time selling this and bringing in that idea to life. Yeah, no problem.
Okay. Any other questions? Okay then. So thank you again.
Thank you so much.
And we're about to have like 15-minute breaks with the final talk. So see you there.